Hello everyone, I am Dr. Sandip Chakraborty and Associate Professor at the Computer Science and Engineering Department at IIT Kharagpur. In this talk, I am broadly going to discuss about my research that I am doing in the past 10 plus years. So my research is primarily in the intersection of computer systems, smart sensing and human-computer interaction, and then take AI and machine learning as an umbrella to solve several real-world problems. So in this direction, we work on the broad vision of what we call as the ubiquitous computing and human-computer interaction. And we are working on various different problems from these three verticals along with their intersection. Primarily on the systems area, we are working towards building up systems that can support last mile applications for the end users. Like in technical term, it is more on the virtualization and resource allocation, developing microservices and executing microservices in such a way so that you can give better quality of experience for the end user. Then working on the debugging and provenance of such kind of systems to do the computation on the edge. From the sensing side, we are working on various type of sensing modalities, including RF sensings like Wi-Fi sensing or millimeter wave based sensing, for sensing the environment, for wearable or earable sensing. And indeed, we are integrating this sensing mechanism with the underlying system where we can execute our algorithm in an optimal way to give the best information or to give the best quality of experience to the end user. And from that perspective, if I talk about HCI, we are working on different kind of verticals like smart transportation, smart living space, understanding the human behavior, both the physical behavior as well as the cognitive behavior, and also in the direction of digital health. Now, in these different verticals, we are continuously publishing in top conferences in this area, which are ranked as A or A-star conferences as per the core ranking and are very prestigious for the CS domain. And also we are publishing continuously on different SCM or the IEEE transactions. Now, as an example problem in this vertical, I will talk about a couple of different problems. The first problem we are solving is in terms of understanding the Alzheimer's or the dementia, which is a progressive neurological disorder, and people get problem with language, orientation, and others. Around 50 million people worldwide, they are suffering for such kind of problem, particularly the old people who have aged more than 65 years. Females are more affected, and as a result, people are getting withdrawn from their family and the society. Their bodily functions are lost, and ultimately that leads to death. And with such neurological disorder, typical life expectancy following diagnosis is roughly 3 to 9 years. There can be several stages of dementia, like early cognitive impairment, mild cognitive impairment, moderate cognitive impairment, or severe cognitive impairment. But it is important to detect these impairments in early and the mild stage. But this is a very challenging problem because for the older adults, they might have decline in their physical abilities because of their age, and that way it is difficult to figure out whether the impairments are because of the cognitive impairments or it is because of their body is not functioning properly. Now, in this case, the patients typically come to the doctors at an advanced stage where the doctors have nothing much to do. So the research question that we have asked in this project is that can we precisely monitor the behavioral changes and auto-trigger warnings to the caregivers when the symptoms of early cognitive impairments or mild cognitive impairments are observed. Now, the typical treatments in this case include monitoring and changes in the lifestyle at the early stages that can be very helpful for such kind of patients. So what we developed that we used pervasive sensing mechanism to monitor the activities of the individuals to detect the early cognitive impairment or the mild cognitive impairment. And our notion was to come up a smart wearable system along with a smart application through which they can monitor the deviation of the behavior of the older person, and it can use the AI algorithms to detect whether that deviation is due to the body function or it is due to the cognitive impairments. And based on that differentiation, it can generate early warnings as a part of the application to the caregiver so that the caregiver can monitor such activity patterns, not only the activity patterns but also the recommendation to understand when to take the person to the doctor for further diagnosis and analysis. So we came up with a smart mechanism like to detect the anomalies in the daily activity pattern, and this part have been completed as a part of a joint Indo-US collaborative project funded by NSF and DST. Then we developed method to detect anomalies in cognitive behavior. Finally, we obtained the anomaly signatures, and also we have looked into the impact of environment on such kind of behavioral anomalies to finally come up with a prediction system and the end-to-end device with the wearable as well as the smartphone application to predict the level of cognitive or functional disorders. In another work, we actually came up with a smart device to understand the environment and its impact on the activities. As we know that air pollution impairs verbal taste and the effect becomes stronger as people get aged. So the environment pollution has a negative impact on the cognitive behavior, and that way we also came up with a smart device to understand the environment pollution through age-based AI mechanism. So if we look into the existing pollution monitoring devices, the typical challenges that we have are the following. First of all, they are costly, they lack of specific sensor for indoor monitoring, they are difficult to configure and control remotely, and they are also difficult for automated annotation. So we came up with a device called Dalton, which also has the embedded AI to understand the changes in the pollution level within a room and how it impacts the cognitive behavior of the individual by combining its output with the wearable device that we have developed to understand the cognitive behavior of the individual. And we are doing a large-scale deployment of this device in different households, monitoring the activities at different spaces, like when the person is cooking, when the person is living or working. And from there, we actually came up with an end-to-end system which can understand the environment, which can understand the human behavior, and then combine them together to finally come up with certain kind of recommendation. So in terms of achievements, we have received the Google Award for Inclusion Research Program in 3 consecutive years on this particular work, in 2023, 2024, and finally in 2025, when we have been awarded with $100K US to carry forward this particular work. Also, we have received IBM OSCP grant for our research. A couple of our students have received Prime Minister Research Fellowship or TCS Research Fellowship. We have received multiple best paper awards, and we have multiple government and industry funded projects in this direction, not only from the government agencies like DST or ANRF. We also have funded project from industries like Intel, Ericsson, HP, and so on. So with that, I would stop. So our group research page has more details about our research, and we have made the codes and repositories open source. We executed multiple such interesting projects in the broad area of ubiquitous computing. If you are interested to know more about those projects, you can go to our group website and look into the project details. Thank you, and thanks for your time.